Wayne, you're in reverse.
Reverse?
Reverse, yeah.
One hop this time. One hop this time.
Wait,
One
stop.
hop.
So, reverse.
Reverse?
Yeah, reverse. Like, go back to where you were.
Well, that's not how the song goes. But anyway, we should go on to factorising.
We should factorise it, yeah.
Okay.
Sound it out.
This is the reverse of the expanding the brackets. And
It is.
How do you do it, Triv?
Well, you start with a thing outside of brackets and you put it back in.
And that would be called factorising.
So if we had the example that we had before, that we got out of brackets, which was 4x plus 4, what we want to do is we want to put it in brackets. So we take out a common factor, which is 4 in this case.
It is in this case. You can take out a 4 because it's in both of these. And there's an x in that family, and times 1 would make 4 in the other. So then when you expand it back out, you'd get 4x plus 4, and that's what it means to reverse it.
Yeah, and that's a good way to check as well.
It's always to expand at the end, and that's a simple one. How about I give you a harder one of this particular calibre?
Alright.
9x plus 3. What can you take out of that?
Well, you can take out 3, Wayne, as it's a common factor between these two things.
You put a 3 outside, it's the highest thing.
It is.
What would you have to times 3 by to get 9x?
3x, Wayne.
Yes, because 3 times 3 is 9, and then you just leave it as an x.
Yep, and then
what about here?
just plus 1, Wayne. Because then, it's like I feel like I'm on countdown. Have a consonant, please.
Very good, very good. One more hard example of factorising in this way, just a little bit harder in a way, is y squared plus 2y. What's the factor you could take out there? Well, in this case, it's not a number, it's algebra.
Yeah, it's the algebraic term of y. So we take y out, and it comes y at the start. Y times y is y squared plus 2. 2 times y is 2y.
Slightly harder, I guess, because it's algebra on the outside, whereas numbers are normal.
But it's not just a one bracket, as we found out, expanding, sometimes it's 2.
Unfortunately, it is. This means there'd be a x squared in it somewhere, or y squared, or an m squared, or something like that. Normally an x squared.
You'd have a squared, one of a constant, and then just a normal number.
Okay, so.
Alright.
And it's normally equals 0. Doesn't really matter either way. If you
No.
wish to factorise it, it doesn't matter.
So, you're going to put it into 2 brackets. So, we'll put the 2 brackets out to start with.
Yep, because you know it's going to be 2 because it's an x squared formula.
Okay, so what had before, we had an x at the start of each one.
So the reason for that is because when you times the first by the first, you get x squared. Because again, when you expand this, you want to get back to this original version.
Okay, and then for the next bit, there's a bit of a rule. You want 2 numbers here that will add together to make this number, and times together to make this number. So this is where we've caused a problem. Wayne's actually made something you can't factorise.
Yes, I did it the wrong way around. I was thinking, cut me a little slack. I do think of these on the spot.
It is, yeah.
You do
It's
the
quite
other way
hard to
round.
think in reverse because you have to think of the already factorised thing and then expand it to think of it. But yes, now we need to find 2 things.
God. Sorry, thinking of it on the spot's really hard. Right, now I'm ready.
Yes, you do appear to be. Do you?
Yes, you want 2 numbers that times together to equal this and add together to equal this. Now,
Yes,
the factors of 8 is 1 times 8
Yeah.
and 2 times 4.
Yeah, and I think we're on a winner there. Because 2 times 4 is 8 and 2 plus 4 is 6.
So, there you go. Oh, it's really hard to think of these on the spot. I'm sorry about that.
Yeah,
So
and then you
if
can
you
check
expand
it
this
by
out-
expanding it.
Yeah.
You'll get that expression there.
Oh, M's giving us a signal that something loud is about to happen. I should probably stop working for a second.
Oh, we should. You got anything to pass the time?
Oh, I do actually. Have one of these?
Oh, I want Rubik's cubes.
Exterminate! 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 Ain't nobody got time for that!
Sorry about that, we
That
can't
was
help it.
Yeah, stuff happens.
Stuff happens sometimes.
Yeah, that's what you get when you mix salt with pepper.
So, there's one more thing to do with factorising, and it's called the difference of 2 squareds.
Is that a circle, Wayne?
No, no, not quite, I'm afraid. Difference of two squares is not a circle. If anything, would it be a rectangle?
Maybe.
Anyway, so it's a rule. It means something like x squared minus 9. This is a squared, as you can see quite clearly. This one, a bit harder to notice, is also a squared because 3 squared equals 9.
But there isn't a number with something x in there, which means the two things add together must equal 0.
That's right. And the way you do this is you have the normal, you have two brackets, one with an x at the start, one with an x at the end. Then you take the thing that squared equals this, in this case is 3, and you plus it in one and minus it in the other. And that's just a rule you need to know, and it's really hard to recognise. It's A star level.
Yep.
You have to recognise that the final number is squared, and it only works if this is a minus. Because if you expand this out, you've got x times x is x squared. Then that looks like an equals there, sorry. I was trying to underline it. But then x times that is minus 3. Then when you plus 3x, it gets to 0. 3 times 3, but that's minus, is minus 9. And that's why it has to be a minus between the squares for this rule to apply.
Absolutely. And this is really as hard as it gets, which actually isn't too bad.
Except I can think of one harder example which may be asked. It's to do with the difference of two squares.
Okay,
just to make it that one step harder.
Let's get serious now.
And it's still A star because it's still the same thing you've got to notice. 25x squared minus 9. In fact, minus 16, just to change it from the previous.
Okay, so we have a squared, not a squared, but you have another one. So of this one, 4 squared equals 16, but this one, 5 squared equals 25.
Not 52.
Not 52, sorry. So what you do here is you have your two brackets like you normally do, with an x at the start of each, but it's not just an x at the start of each, is it, Wayne?
No, because it's a squared times a squared, in the brackets it's a square times a square, it's a square root times a square root.
Yeah, so you
now
have
you've
5
got 5x
times 5x
will equal 25x squared.
It will.
And then for the next bit you do the same.
Same as last time, so you have plus 4 and then minus 4, which will get rid of the in-between terms and just leave you with minus 16.
This is really hard to spot, it's the top grade stuff, really hard to do, but here's a video, hopefully you'll remember. Sorry about the noise in the middle,
Yeah.
and Emma's signal is again, I think.
I think that means your oranges are ready, Wayne.
No, I've seen that face before, we were unsuccessful, the mission's still going.
Oh no, I want an orange though.